Everyone, in this video I am going to discuss about the diatomic molecule and the energy level diagram of the diatomic molecule. First I will discuss about the definition. The diatomic molecules are simply the molecules having the two atoms of same or different chemical elements. We all know about this. For example, H2, in this case both the elements are the same. So actually there are two hydrogen atoms, okay. Both of them are hydrogen, similarly oxygen, and actually they are called homonuclear. And on the other hand, there are some molecules like a diatomic molecule but having the atoms of the different element. For example, this is carbon monoxide. This is also the diatomic molecule, but here the two molecules are here the two atoms are of the different element, like copper and oxygen, and similarly others. So it means that diatomic, in case of the diatomic molecule, the molecule can be, the atoms of the molecule can be same or maybe different, okay, but it just consists of the two atoms. That's the thing, okay. So let me going to discuss about the rotational energy in case of the diatomic molecule. The rotational energy will be given by the rotational kinetic energy will be given by, this is the formula, L square divided by 2I, where L represents the angular momentum and I represents the moment of inertia. I represents the moment of inertia. And then this one for microscopic atomic level system like molecule, angular momentum can have specific discrete values. For example, L square is equal to LL plus 1 h cut square. So L is non-negative integer and h cut is the like the Planck constant, reduced Planck constant, means h cut is equal to h divided by h over 2 pi. So the I is equal to the moment of inertia. The formula for the moment of inertia is mr square, but in this case, in place of m we just replace it by reduced mass. Mu is the reduced mass of the two atoms. So this is the thing. And then where mu is the reduced mass and r0 is the the average distance between the centers of the two atoms. So if we substitute this value to this L squared divided by 2I, so L plus 1 s got square, and in place of I, mu times r naught square. So where the values of uh, L is the azimuthal quantum number. So its value should be from starts from 0 and 1 to and 2 and like that. So if we replace this h code square by h by 2 pi, so h square divided by 4 pi square, and then in the denominator we just replace mu r not square by I, because I, that is the actually the I, and then LL plus 1 as it is. So we just write EL or E rotational is equal to L square over 8 pi square I LL plus 1. So now replace this by EL is equal to B at LL plus 1, where the B means constant, L divided by 8 pi square and I. So actually here we have split h into the two parts, as square into the two parts, so that's why. So and then here the values are, we know about that. So if we do so, then this is the energy level diagram. The lowest level, if L is equal to 0, the energy should be 0, because the formula is over here. EL is equal to B at L plus 1. If the value of L is 0, then obviously EL is equal to 0. And then if we put the value of L is equal to 1, then its value should be like 2BH. And then similarly we put the value of L is equal to 2, we will get 6BH. And then if we put the value of L as 3, we will get the 12 bs. So if we look at to the difference of the two levels is like this one, 2 bs, because the difference of 2 bs and 0 is 2 bs. So difference of the 6 bs and 2 bs will be 4 bh. And then similarly this is you can guess now the upper difference of the energy will be 8 bh, and then similarly goes on. So